Yeah, my name is Wim Henderickx. I'm head of technology in IP, so I work for Vatch, and I had the pleasure, so Vatch has this dream, if you will, right, to say, okay, can we use or consume the network as a program, right? And I said, okay, I was tasked, okay, so how do we go about doing so, right? And what I want to do in this session is go through the journey I went through and what technology is out there that led us to basically decisions on how we evolve our networks to be more consumable, stuff like that. Now, when I looked, so the first thing that I did is I said, okay, how do we go about that, right? Because we are today, and this may be not true, but a lot of networks are still operated through CLI, right? And so there is, I call us the CLI jockeys sometimes, right? And if we want to succeed with the 232 tool, or whatever you call it, what we have to achieve is somehow make that tool the thing that people love, right? Because what the goal is actually, or at least that's how I perceive this, is that if we prevent, or if people try to use the network through, that's what we call a controller or automation orchestration. So there is so many tools, right? So, but if we succeed in a platform that allows people to use that and they would love that, and we avoid them to go to the command line, then we succeeded, right? Now the challenge here is, one is, as Mike was alluding to, a lot of effort has happened to make, to focus on speed, right? But I think what I felt is that speed is good, but reliability is even better, right? So, and if you can do both together, that's a hit, right? And then the third dimension that I want to put into the picture is kind of what I call life cycle, is that if I look to this tool, this is not we sell you and it's done. When we talk about automation, it evolves, right? So we need to basically, so I call them three currencies, which is speed, so or confident, or making it consumable, reliably, right, with confidence, and third, trying to keep up with that, with all the changes that are happening within the network, right? If we succeed in that, we have a hit, right? So maybe the 232 tool might be the one that we are going for.
So I think this slide right here, any data center network vendor could use this exact same slide.
Yes.
So I think what's going to be important is the differentiators.
Correct.
Because hardware's hardware.
Yeah.
Who cares about speeds and feeds? Every vendor can match those speeds and feeds. It's all about the orchestration, the automation. Yeah. It's all about that layer right there, the controller-based systems.
Yeah.
So
agree, and that's basically what I wanted to highlight. What differentiates us? Because we looked we said, so Vatch said, okay, go look how we would go about doing that now. And what you see is that there has been a lot of technological advances that has happened that helped us to achieve those three currencies that I was talking about, right?
And one thing we're always talking about is EVP and VXLAN.
Yes. Yeah.
So, having that underlay and overlay. So it'll be interesting what you have, what your solution is around that.
Yeah. Okay. Yeah. Now, first thing that I did, so I bring the big elephant out of the room. So you have a lot of people get scared when they see this, at least in the networking side. And I wanted to drill into it. So we looked at, if you look to automation, orchestration, and stuff like that, outside of networking, that is the tool, right? So now, if you look at Kubernetes as a vehicle, you could actually split it in two sections, right? One is really, it was built for container orchestration, right? But they also did a pretty interesting job, is actually the machinery that sits inside is actually very extensible and allows to actually go for other use cases. And what we have seen, my analysis basically said, although container orchestration was their first use case, in the meantime, there is various other industries that are adopting the second piece of Kubernetes, right? Okay, which is the machinery that allows for automation and orchestration, right? And we'll zoom into how that looks like, right? Because I want to build a bit of an analogy. So first of all, what did Kubernetes actually do when they focused on container orchestration, right? They did a few things, which I summarized on the slides, right? So they basically, I think, first of all, they divide and conquer, right? So Rita, you mentioned EVPN VXLAN, right? Mm-hmm. So that's the currency or the technology that we use in networking. They have containers, they have servers, so they had to deal with a different problem space. But what they actually did is they dissected that problem space into multiple components, and you see some of them here, right? Services, pods, containers, nodes, and stuff like that. So there's a bunch of objects that they created, right? And they built a set of abstractions, right? Beyond that, right? And they kind of built what they call, what we refer to as a declarative API. So in other words, we like that if you look to a consumption model, you basically say, I want this, and someone will take care of making that happen, right? So that's nice as a technology to actually do automation, right?
And when you say declarative, you mean declaring intent.
Yes, and what is important to notice, right, and that's always the challenge, I think intent, in my view, is a word that has been misused.
Sure.
And I avoid using intent, but we are actually using real intents, as you refer to. But intents are used in two purposes, in my view. One is the declarative aspect, and the second is the abstraction, right? Now, when you see on what Kubernetes did, they use abstractions at the lowest level, all the way up to a higher level. So what I try to depict in this slide, for example, if you look at the pod, that is the unit that they schedule a container with, right? But to deploy a pod, they added another resource, which is a deployment, right? And if you want 10 pods, you basically say in the deployment, I need 10 of these things, and it will basically roll out 10 of these things, right? So in other words, they didn't just use abstraction at one level, but they used it across the board, right? So that is actually, and they did, so you could say all of these things are intents, right? I avoid using the term because I believe it's a bit overused and overhyped, and it creates confusion, right? But in essence, that's what they do, right?
Is Nokia taking advantage of this transition, or are you being enlisted to help them make this transition?
So we looked at this technology, right? So you will see in the next slides how we apply this to networking, right? So in other words, what is the crux, or one of the crux we believe is important, is rather than reinventing the wheel, let's see what is out there, and let's see, can we apply what is good and what needs to be enhanced to actually solve the networking automation space and the use case that Vaj was alluding to and Mike was alluding to, right? So that's kind of basically what we did. So in other words, this slide is Kubernetes one-on-one, right? But it's not relevant for us because all of these resources doesn't matter, right? Now, so what is also interesting is that they have this, what we call event-driven mechanism, and I'll dwell into it. But so you have active reconciliations, you have abstractions, you basically divide and conquer and stuff like that. So I think what I personally did is I looked at the landscape and said, okay, actually they did a pretty decent job, and tried to understand how to apply them to networking, right? If you look at networking, right, and so this is a very simplistic view of the situation, right? So I said, okay, if I look to networking, so if you look to container orchestration, then basically you have a deployment, you have a pod, and you schedule it on a node, right? It's a very simplistic view. But if I look at networking, I have my EVPN virtual network, right? Whether it's layer 2 or layer 3. I have a bunch of interfaces, and I have VXLAN. So I basically abstracted the picture here to simplify it, and I have to configure a bunch of devices, right? So basically, if you look at it, what is so different between the two? It's basically, if you summarize it, it's the objects. By the way, I sometimes call resources. So each of these bubble is a resource, right? So a resource is an API, right? And an API is a schema, and you do validations and stuff like that. So each of these things is a resource that basically set to do something, right? What that is, it's up to you, right? So in Kubernetes, they have a controller that takes that object and does something with it. For example, scheduling a pod. So they basically start up a pod, right? What we would do is if you create an interface, We probably say we want to configure something on a device, right? And figure out if it's Nokia, it's going to be this configuration, and if it's Arista, it's going to be this configuration, right? So that's kind of the difference, but if you look conceptually, it is very much the same, right? So I said, okay, can we go about that, right? Now, of course, Kubernetes was focused on container orchestration, right? And we talked about this notion of declarative, right? And I think we had, in the industry so far, we have two issues, right? One is we created new APIs, right? So you know about Yang, we have Netcom and stuff like that. But if you are a CLI guy, right, and you now have to go automation, which is one of the questions you asked for, it's different, right? It looks always very different. Like you need XML, JSON, so it feels awkward, right? So as a person, you have to learn some new stuff. If you look to this picture here, so what I try to depict, the left is CLI at the bottom. The right is how the API would look like from Kubernetes. So just look at this payload and compare it to that payload. Do you think that automation engineers would be able to do this? What I'm personally feeling, it is way more the same, right? Because if you look to that payload at the bottom, the payload here is the same, right? I mean, it's just, okay, you could say it's YAML,
Yeah.
right? But the way to interact with the system is like, apply this thing, and it will take care for you, right? You do a change here. This is a very simplistic scenario, but let's say I add a VLAN, right? And you didn't have it. The system will figure out, because that's declarative, how to accomplish that, right? It makes it simple, right?
It's very parsable, right?
Yeah.
You've split everything out into discrete fields and information elements.
Yeah.
Other vendors have tried to do this with their CLIs in the past too.
Yeah.
So.
Yeah, correct. So, and for example, this is not an abstracted interface. This is basically a one-to-one translation from the device through a declarative interface. So in other words, if you had Cisco, this payload would look different than if it would be Nokia potentially, right? But as an automation engineer, I have the feeling that to interact, or let's say to go to an API type of thing, this has a way better look and feel. And for people familiar with the CLI, it's much more easier to conceptualize, right? Now, so first thing that we did is, okay, is this possible? The answer is yes. And can we do that in a vendor agnostic way? The answer is yes, right? So now, okay, let's move further, because now I can interact with a device in a declarative way, and it doesn't matter which vendor it is, right? So that's, okay, let's move on. Now, it's nice to interact with devices on one by one, and what you saw before is basically the API that would interact with a single interface, but we are all about network-wide things, right? So we want to create your VXLAN EVPN, which I call a virtual network here, and all of a sudden the configuration of the whole network would be spit out and basically be configured, right? So how does Kubernetes, so my previous slide on deployment pods and stuff like that, this would be a dissection of how the network resources would look like, right? Now, the interesting part is Kubernetes gives you all the freedom to define any resource you want. So it's extremely extensible and it's customizable. And the terminology that we use is Kubernetes resource model, right? So it's extensible. So what we did, or what I did here, and you'll see that also in IDA, is that we basically came up with a model to basically dissect the problem space in concrete objects, right? Why is that important? Because I'm a big fan of Unix philosophy of doing one thing and one thing well. That means that my code, or the thing that sits behind, that takes care of that sub-interface object, does only one thing, taking care of that sub-interface. Now, the other important thing, which is, I think, what makes it really interesting, is that it's all event-driven. So, and if you compare that to an Ansible and a Terraform and stuff like that, they do not have that capability. Now, why is that important? Or is that what you typically see with a tool like Ansible and Terraform, you basically get something at the top and they spit out something, right? And they do that fairly well in an easy way, right? So they do a pretty good job at it. Now, if you run this in a live environment, for example, let's say someone recreates an IP address on the fly on the box, right? What happens in the Kubernetes model, an event is triggered and this thing will figure itself out. So that means that it's not only a top-down, but it can actually be triggering and gets events at every level of all the resources that you consume, right? So that is actually also very nice, because one is you get the one thing and one thing well. The second thing you get is everything can trigger something into the network. So that means that I think in summary, the life cycle to maintain this product is going to be way more easy. Right? And that's one key aspect of it.
You were talking about, just a quick question on that. You're mentioning it'll make it easier to maintain the product. I feel it'll make it easier to adopt the product too, because you're not cutting off access to the CLI. Like if a traditional NetEng is making a change there and then it's, consumed into the system through an event or whatever and spit out in
100%.
in your YAML format or whatever.
Yeah, 100%.
Yeah.
And so they also, I was of the opinion, okay, I'm still a CLI guy, but I'm of the opinion that some automation systems, they say, I'm going to give you that network-wide API, but don't touch this box anymore, right? So you can no longer access. And what we end up saying is, no, we should still allow that, but okay, reports and stuff like that, right? So it's not just, we just cut you off. We still allow you to do so, right? But because there is, we have to prove that this tool is going to be the tool that all of you or all the operation people would love eventually. And that's still to be proven, right? So in other words, we still have an operational mindset where people go onto the device and we didn't want to cut them off, right?
So I have a follow-up to that then. Yeah. It's been mentioned a couple times about a source of truth.
Yeah.
What is your actual source of truth then in this situation? If
so, the interesting
when you can change configuration, the new way, the old way, like how do you know what to trust? Yeah.
Correct. So very good question, right? So if you see the system, you can actually build a source of truth within the system. But for example, I think 2 weeks ago there was a Kubernetes operator released for Netbox. Right? So we would just integrate with that. You see? So in other words, we are so the technology allows us to be flexible on how you consume it, right? What we are kind of, what I'm trying to say at this stage is that we all benefit from using KRM as an object model to model things, right? And to interact with, because the advantage is that, one, networking is not unique or not, snowflake is maybe a bad word, but sometimes what we typically do is we try to do something which is only for us. What also I like about Kubernetes is that there is a huge ecosystem. Go to KubeCon and you get 15,000 people. You go, there's a meetup almost every month in a country somewhere. You have a huge set of people and skill sets that you can tap upon to help with your automation journey and stuff like that, right? Okay. I need to speed up in terms of time. Now, so a few more things, right? So, wait, I forgot one thing here is that Kubernetes is good for configuration. What you typically see in the tooling is that state, so meaning operational state, is lacking, right? So, and even Kubernetes doesn't do a very good job at it, right? So if you look, is it all green? No. So there are some things that we believe needs to be enhanced, right? So state meaning really getting the operational state into this system is going to be critical, because you don't, if we talk about predictable and operating a network with confidence, it means that we have to say this didn't work, right? And we have to be able to then do something about it, right? But the system allows you to consume that, right? So it's not that you cannot make that happen. Kubernetes by default doesn't, okay? Now, I have 2 more slides, so I'm really running out of time. So the other important thing is change management, right? Because right now we say we have a declarative interface to the system, right? We can orchestrate and look at the system as a network-wide element, of course, what do we do for change management, right? Because, and we want to have guardrails, right? The tool chain that Kubernetes basically developed is GitOps, right? So you basically check into Git, right? You know the revision of what you want to push and you get that down, right? Now, one aspect of what we did not like about Kubernetes, or by default, is that it has this concept of eventual consistency, right? Now, it doesn't sound right when you talk about airplanes, right? So we wanted to, we felt that we need to make this rock solid. So if you do a change, right, it either works or it doesn't, okay? And this what gives you the confidence, and we will also tell you it will work ahead of time. We don't even try to transact, right? So we wanted to actually do that with confidence. What I also felt when I did the analysis that although they have Git and they have good tooling, Git is not integrated completely, right? So if you look to a router these days, we all have candidate configurations, right? If you look at Kubernetes as a product, you apply and it goes live, right? That's also not a good attribute. So we felt that Git has to be integrated integrally into the system so that you actually, your state has an immutable object and you can basically go back and forth around that, right? So to conclude, so we liked, so what is in green on the left, right? So we liked a number of these things, right? There's a few things that we felt needs to be enhanced, but is it a showstopper? The answer is no, right? So what are the things that we felt that needs to be enhanced? Is reliability, right? Confidence, right? Because we wanted to do a transaction and say, okay, this will either work or not. And we, like Tom was alluding to before, we don't want to run on a half-baked network that is a bit in a flaky situation, right? We wanted to have reproducibility because even though a change succeeded, there might be a ripple effect that we didn't see at the time, so it might happen later. So we wanted to do what we call reproducibility, is roll back at a certain checkpoint that you have, right? And then we also felt that state has to be incorporated because it's not just about pushing configuration. You actually have to basically see, okay, what's happening and correlate the two, right? And then, although KRM and it's extensible, it was not as easy as we thought it had to be, because we are talking about networking people and you go to a new space of automation, right? Then we wanted to make that easier. Now, is that important for everybody? No, right? Because if you look to my recommendation when I said to Vaj, is okay, I would say take the core of Kubernetes, right? And extend it with the things that I was alluding to, right? But build a product that is extensible, because automation, we have an opinion from Nokia, right? But you go to a customer and people have different environments. We need to be flexible to customize, right? And that's for me the third currency that I was talking about. The life cycle of this product needs to be easy to consume, right? So that means that we have to keep that up to date. And the people who are able to do that, I think we see different usages. One is people consume this as a black box, right? And they will ask Nokia to actually do the change. But even for us, it's important to not ask the best engineer who is available for 10 other things to actually customize it. We benefit if people that are not so skilled in the core technologies to be able to extend. And that's true for partners, that is true for people who consume it by themselves. Of course, if the product or if the tooling is as you want, you don't have to do any of that. But we wanted to build a system that allows you the flexibility that if in case you need it, you have the choice or you have the flexibility to customize, right? So that's why there is, if you look to the product from before, there is the green side, which is the extensibility, and there is the red side in the middle, where we said this is our core, where we solve the 4 things that you see on the top. And that was my recommendation to my boss, and then we'll see what happened next.